Hey everybody, and welcome back to part 2 of our sound unit. And this is all about how does sound change. It's got to try real hard and make good, healthy choices and changing its habits. No, wait, completely different types of sound changes by, well, you'll see. I'm going to the corner. Hey, we're going to take a look at the properties or the characteristics of sound, okay? Because we can't physically see sound, but we can diagram it. Oh, yes, we can, because, parts is parts. This is a typical wave diagram. And if you've ever been playing around on your iMovie and on your iPad or your phone, and you look underneath the video and there's that little squiggly line, that little squiggly line is actually the sounds that is going on in your video. You'll note that when it's really loud, that squiggly line is great, big, and huge. And when it's really quiet, that line's real tiny and small and flat. True story. The crest of the wave is the peak of the wave, or the very, very top. Oh, look, I bet you want to write that down on your worksheet. Just a subtle hint. The second one is called the trough. Now, this is at the bottom of the wave. And if you've ever been swimming in the ocean, you can think of it this way. Here's you, the little star, standing on the bottom of the ocean. The waves, or the water rather, is right around your waist. And here comes a great big wave over the top of you. Well, that part right at the very, very top, that is the crest. And when you're in between the waves, and there's a great big huge wave right there, and there's another great big huge wave right there, and you're right in between them, you're in the trough of the wave, or the bottom. Make sense? Sure. Wave height, well, this refers to the distance from the middle of the bar to the crest. Or, to put you back out in the ocean, the water, it's right here on your waist, right? Well, if the crest of the wave is right here over the top of your head, that's the wave height, from the water to the top of the wave. Or in this case, the middle of the bar, or that green line. Now the wavelength, this measures the distance between two crests. So again, if we're back out in the ocean and there's a whole bunch of waves coming in, it would be said that there would be a high frequency of waves passing over the top of you. But if it's low tide and not a whole lot of waves happening, there's a wave, and there's a wave. Okay, yeah, that would be a low frequency of waves passing over you, right? So, not that I ever like to scream and shout a lot. How loud can it get? Well, the loudness of a sound is measured by the height of the wave. The taller the wave is, the louder that sound is. This is also known as amplitude. Yeah, that's a big word, and yeah, you're going to want to write that one down. Again, the loudness is measured by its height from the middle line to the crest. Amplitude refers to how loud or quiet a sound is. Amplitude is measured in units that are called decibels. Not decibels, but decibels. The abbreviation for decibels is a little d and a big B. Oh, it's him. Do you want help? He has a question. That was kind of loud. Oi, I can guess. What about you, Dora? What do you think? That's right. She's my star student, Dora. Dora says B, Hal. He's going to keep us in suspense. See, we're smart. So, if we were to chart B's sound on the bar graph thing there, it might look like that, with the crest getting right up here, right on the very top and the very bottom of the wave, as it spreads out evenly from the center line. But if we take a look at A, not quite as loud, and it would look more like the red line where it's a shorter wave height. Sound B is going 2 full bars up, whereas sound A is just going 1 bar up. Make sense? Sure it does. Notice the difference in the heights of the wave from the center to the top or from the crest, right? A, big. B, not so much. Buzz, buzz, buzz went the honeybee. Sing along, twiddly diddly dee went the bird. Come on, I know you know this one. What do you mean you've never heard of that song? Really? Kids these days. So what determines how high or low a sound is? Well, the distance from the crest of one wave to the next determines how high or low it is. We refer to this in terms of sound as its pitch. Not throwing the baseball or the softball. But pitch refers to how high or how low a sound is. It's bold-faced. The longer the distance between the crest, the lower the sound will be. The shorter the distance between the crests, the higher the sound will be. The distance between the two crests is known as frequency. Frequency is measured in a unit that is referred to as hertz. Because if it gets too high, it hurts. Okay, not really. Oh, kind of, yeah. And the abbreviation for hertz is a big H and a little Z. Yeah, it's him again. No, I didn't. Picks on me. All right, here we go. You ready? I can do this one. That was uncomfortable. That was, what do you think, Dora? Yeah. A, definitely A. Much higher pitch than sound B. Again, if we were to map these sounds, sound B might look like this. It's loud. Frequency close together. If you look at the wavelengths, they're kind of close together. But if we stick A on there, not only is it melting my earlobes, but you see how close together the crests are. Many more waves passing over a point at the same time. Again, to put you back in that ocean, right here, here's sea level. Here's you standing here. You got 3 waves passing over you in, say, a minute's time. But over here in this ocean, you got many much more than 3 passing over you within a minute's time. And that is what determines the frequency, the number of waves that pass over a given point in a fixed amount of time, usually measured in what are called milliseconds, which is a really short amount of time. I just said all of that. Yes, I did. With sound A, the wavelengths are much shorter and the tone is much higher in pitch. In fact, sound A is 4,000 hertz higher than sound B. True story. Oh, bad things are going to happen. This is awkward. Seriously, Hal. He's on fire. Well played, Hal. Well played. I think he has a little flair for the dramatic, really. Okay, so here we have it. We have 5 different waveforms, and using pitch, volume, frequency, tone, all that stuff we just talked about. I want you to tell me which one is the loudest, which one is the quietest, which one has the highest pitch, and which one has the lowest pitch. I want you to hit pause right now and answer those 4 questions for me on your worksheet. Ready, go. Okay, so you've unpaused me now. If you haven't paused me, pause me. No cheating. I'm watching. Let's take a look. Which one has the loudest sound? Well, to do this, we need to look at the height of the wave, right? And if you look in here at C, C is all the way off the top. If you're looking at A is barely off the center line. So clearly, C is going to be the loudest one, right? Which one's the quietest? Well, I think we kind of just stepped in that one because A is just barely off of the lines. This has got a whole bunch of them, but that's touching our second bar. This one also touching the second bar. This one's over the second bar, approaching the third. So clearly A is our answer here. Hey, we're 2 for 2. Way to go, Dora. All right, which sound has the highest pitch? Now, this is in terms of frequency, the number of wavelengths passing over a given point. What do you think, Dora? That's right, that's right. The answer is D, because again, if you look at all of these wave crests all jammed and squeezed together in that little tiny place, that's a really high frequency sound. Which one's the lowest pitch? Yeah, you guessed it, E. E just has 2 crests. So E is going to have an extraordinarily low sound. That's everything I got. Good job on your quiz. Thank you for tuning in. We got one more after this, and we'll be done. Thank you all for joining us. Have a great night.